Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We continue looking at graphics, and we have moved past the settings on the graphics 2D, and now I want to talk about images. So in the previous videos, all of our drawing went straight to the screen. Okay, we set up a panel, we overrode the paint method, and we put in our own paint method in such that anything that was painted appeared on the screen. Sometimes you don't want everything to be just up on screen. Maybe you want to have stuff drawn off to the side. Maybe you want to have some way of kind of saving off the things that are being drawn. And maybe you just want to be able to, for example, load in from files other things that have been drawn and then take those and draw them to the screen. And so for all of these types of functionality, we want to use the image type. And so there's a java.awt.image, and we can go look in the API at that. Java.awt has a class image. Now the image is remarkably generic, which also means that it really doesn't often do that much for us. There are lots of subtypes of image or that you would use, most of which you can't really get to. They're used for particular situations. In general, we're going to be using a buffered image. And so note, this is in the package java.awt.image. So the buffered image does kind of what its name says. It stores off an image, and it stores it in a raster, which means that it stores it in a grid of little pixel values. Now, all of the images that get displayed on a computer screen wind up being rasterized. The general image has the ability to store images that aren't necessarily rasters. They aren't made up of little drawing elements. They can be, for example, vector graphics. And things like that means that makes the image more flexible for working on things like a printer. Okay, so you would actually have the ability to take and create an image and send it out to a printer or even a line printer, which you'd have a hard time finding these days. But it would give you the ability to actually utilize the vector capabilities there. The buffered image works very well for our purposes, where it stores everything as a raster. And so when you create a buffered image, you give it a width and a height and a type, and the types are listed up in here. I generally use the type int argb, which means that it stores every pixel in the raster is stored as an int, and the argb, so RGB, red, green, blue, the A stands for alpha, which is a transparency. So using this type of image, you have the ability to make your pixels transparent if you want. So we will, I'll generally use a buffered image for storing off images. And let's say I wanted to make my own image. So we had been playing in one file. That file was getting a little bit long. So I'm going to start a new file. We'll call it images.scala. Now once again, we're going to have to import a bunch of things. So I want to import all the swing stuff. I want to import the events inside of swing. I'm going to import from java.awt. I just have a funny feeling we're going to need color, so I'll stop there. java.awt.image.buffered image, because that's what we're talking about now. Val, let's make ourselves a panel. Earlier I called it draw panel, but that's just a variable name. I'm going to go with just panel this time. Override def paint, takes a graphics 2D object, and it's going to draw it to that. Val frame equals new mainframe, and make sure we pop up our frame. I know I've had several times where I write programs that involve GUIs and I run it and it does nothing, and it can take a while to figure out, why did this do anything? What did you mess up? Sometimes just you didn't open the frame, which is why I get into the habit of adding that early. We'll give it a title for images, and for right now I'm going to give it a single thing for the contents, and it will be this panel. Maybe we'll add some buttons later. Who knows? Okay. So now whatever I draw into the panel will show up there. And just to illustrate how this works, first I am going to create an image, make a new buffered image. I get to give it a width and a height, 200, 200, and as I said, I generally use the type int argb. You might find reasons why you want to use some of the other types. This is a good default to go to. Now, let's come into here and say g.draw image of, well, we have to go look in the graphics 2D at the various draw methods. So there's draw images. Notice there are quite a few of these. Well, actually, so there's 2 listed here. There's even more listed if you go down to the original graphics object. The draw image here takes an image, an X, a Y, a background color, an image observer. Which of these to use is kind of, I guess, an interesting question that you can decide how you want to do things. We happen to have a buffered image, but I don't really have an interest in trying to do a buffered image op. We could draw the image and give it an affine transform and an observer. That still seems a little bit overkill. I'm actually going to use the simplest form, which takes the image I want to draw, an X location, a Y location, and an image observer. In our case, we don't need an image observer. An image observer would be, for example, if you're loading images off the internet and you need to keep track of things. In our case, I'm perfectly happy passing in null as my image observer. That will work fine. And if I run this, and if I could spell Java, and I need a 2D there, simple typos. Oh, I didn't make it so it's centered. And when it pops up, it is absolutely tiny here. So I didn't make my panel have a preferred size, and I didn't center it. Let's go ahead and let's fix those things. Okay, so now we have it pop up. Of course, you don't see anything there. So I would need to be able to draw to this buffered image. How can I draw to a buffered image? Well, if I go back here and we look at our buffered image, turns out there are a few ways to do this, and we can look at both of them. So one way is to call create graphics, and that will give us a graphics 2D object that we can use to draw onto this image. So, and in fact, when I do this, I'm going to now introduce a new scope, because I don't want to have that graphics 2D existing in my global space. So I create the buffered image and I make sure that that's the last thing in here. But now I'm going to have a G which is equal to the image dot create graphics, G dot set paint, color dot blue, G dot fill. Because it's easier here, I'm going to go ahead and use the older call of fill rect. And now when I run this, I get oh, I'm like, oh, I made that 300 by 400. That shouldn't be a square, except for the fact that the image I created is only 200 by 200. So I overfilled the image that I created, and this image now has a completely blue background on it. Okay, so I could draw whatever we wanted in here, doing the things that we're used to, and then I can take and draw that image into there. If I draw the image instead of at 0, 0, if I draw it at 100, 100, then whatever image I have will pop up there. What about the other way of doing this? Well, the other way actually doesn't use any additional variables. So inside of the image, the buffered image, there are methods for getting and setting RGB values. So you can ask for the red, green, blue value at a particular location. This gives you an int, and you can set the RGB value as well. Now these RGB values are packed into a single integer, and this is where, if you go all the way back to chapter 3 when we talked about binary and hexadecimal and such, this is where it really comes in handy, because we need to take 3 different numbers and pack them into a single integer, and they go at individual bytes inside of there. Now if all I'm doing is, if I can hard code this, I can specify a location, and let's go ahead and let's make a for x in 1 to 20, y in 1 to 20, image.set RGB, x comma y comma, actually is it xy and then the color, or is it, yes, comma, and then the color I want to use, I'm going to write it in hex, 0x. Now because our image allows transparency, I need to make sure that the top byte is has all the bits on. So this is non-transparent here. We can play with that in just a second and let you see what happens if we take it down. And then next comes red, and then green, and then blue. I'm going to make this so it is completely red. Okay, so I have 2 Fs for the top byte, which is the alpha channel, 2 Fs for the red byte, or for the red byte, yeah, which is the obviously the red channel, the green channel, and the blue channel. And so what I've done is I've run through a little square, and I have turned the pixels onto a particular color in there. In this case, the color was all red. What about that transparency? Well, what if instead of being F7, it was like, or instead of being FF, it was 5F? Well, now that looks kind of pink. It's not really pink. It's a solid red, but it's transparent, so you're seeing the white background behind it. And if I had a more interesting background there, you would see the more interesting background showing through that little, effectively, hole inside of my image. To make this just a little bit more interesting, I would like to, yeah, 0 to 200, this will work fine. I want to make it so this isn't a fixed color. I want to make it so that this is basically a more interesting color. And to do that, I'm going to start combining bits together. I want to have some control over what goes into the different positions. So I'm going to hard code there the alpha, so it's on full. But then I'm going to use a bitwise OR. Once again, you can go back to chapter 3 to look at the bitwise operators. And I want to OR into here, I'll put 2 parentheses, x x times 10, and then I want to take that and upshift it by 16. Okay. Now, what's going on here? Okay, so x is a number between 1 and 20. X times 10 is going to be a number between 10 and 200. And the values that you can store in a single byte go from 0 to 255. So this is a nice number that's between 0 and 255, and it uses pretty much a large fraction of the range. But I don't want, so just values between 0 and 255 would appear in these lowest two digits. Red needs to be up in these two digits, and so I need to upshift this by 16. So if I don't upshift it at all, it's this digit, and remember this is actually 4 bytes here, or sorry, 4 bits here. This would be so this is shifted up 4 bits, this is shifted up 8 bits, this is shifted up 12 bits, and this is shifted up 16 bits. So by pushing it up 16 bits, I've made sure that all of these things are zeros, and it's just going to sit there in those 2 hex digits. And then I will also OR onto this y times 10, but this time instead of upshifting it by 16, I'm only going to upshift it by 8. So that will sit inside of the green channel. If I didn't upshift it at all, it would be the blues. By upshifting it by 8, I get greens, and by upshifting it further, I get reds. And now if we run this, oops, I covered up my old one. Let's go ahead and do y insert plus 20. So we have the red that we had there, and then here we have kind of a gradient between reds and greens. It's the reds are full on this edge, the greens are full on here, and they're both off up in this top corner. So you can get individual pixels and you can set individual pixels using that approach. So that's how we can, the other way to draw things. Most of the time you will do the create graphics and draw into it this way, but if you want more direct control, you can use set RGB. Now what if I actually wanted to draw an image from someplace? Well, for that we would have to go get some images, and I just so happen to have some handy little images up here. So we can save an image. Let's go, no. Into where we're working. We'll save that there, and how about we do Odersky's book. Okay, so now we have two images. They are saved out in the directory that we're in, and I would like to load these in and draw them. So how do we load in files? Well, if you go back to the API, here we're going to go to a very different part of the API. So we'll jump down into the packages that start with JavaX. These were extensions to the original library that were added later on. And there's a package called javax.imageio. And inside of here there is a class called ImageIO, which has methods such as read from a file. And that's exactly what I want to do. Is I just saved off those files, so I want to have this read a file. Notice it gives us back a buffered image. Now art image equals ImageIO dot read JPEG val prog image. I should at least be consistent in how I name those. Prog in Scala.jpg. I'm going to have to import up here, import javax.imageio.imageio, and then we'll come down here inside of our paint, and I just want to draw those two images at two rather different locations. Draw image. Art image will go, I'll put it up in the top left corner, and a null image observer. And this one I will put, say, at 300, 300. Oops, and overloaded method. Oh, that's right. This needs not a string, but an actual file, which we talked about with our scanners back in the chapter on files, but that's going to require, well, the way I've typed it requires another import. You never actually have to import anything. You can just use really long names for stuff, and since I use just the name file, I need to import it if I want that to work. And there we go. Okay, so here we were able to load in these images and have them draw themselves. We also created our own image, and we were able to draw that in there. And in the next video, we'll talk about another technique we can use for where we would want to draw our own images, something called double buffering, and we'll also look at how we can use the texture paint.